and um, um, Elias. I will introduce you to the public. Elias will tell us about a big data project for printed. Elias had been working on this presentation, food printing in the era of the data. I met him during my university studies. He was running a project. After you wrap up your project, we have to work all together. So, in the very end, 90% of this presentation has been done by Elias. I only changed some uh, colors and some slides, but I will give the floor to Elias. Elias will tell us about this wonderful tool he's creating. Elias, please, you have the floor. Elias, footprinting in the era of the big data. Thank you, organizers, for allowing me to be here with you. Thank you, colleagues, my friends. At this very late time of the evening, keeping your interests awake. My name is Elías Grande. As Alejandro said, I'm superior and technical engineer by the University of Juan Carlos. I'm technical communication infrastructures master person. Should be interested in more information, please. You can contact me on LinkedIn. The idea of this project, the mindset of my initial project, the assets we try to cover. What would happen if we stick the knowledge from security along with the knowledge from the branch of architecture and cybersecurity and security? Well, we can get super cool things out of that. This was the initial tenet. Although the name Odin sounds like booklets from mobile phones, is turning around much more around footprinting based upon the latest technologies on big data and distributed architecture. This is my agenda for today's presentation. I'll try to make it as agreeable as possible. But firstly, a contextual introduction, the generical problems. Secondly, a study of the state of the art of the tools, whether they are footprinting tools or desktop or third-party tools and services. Based upon the efficiency of these tools, we will pose the solution, which is the Odin project, and finally the conclusions we can draw out of this project. Regarding the inventory of assets inside CMDB, it's a well recurring process. The highest profiles into managing IT, there will be very familiar with the good practices, and along these good IT practices, we'll find the concept of CMDD concept, which gathers all the information from the infrastructure in a company, their interrelationship among elements. As of today, there are no isolated elements. All elements are interrelated in order to give one or more services. Regarding the concept of CMBD, we'll find the inventory of assets publicly, the part of published assets on the internet. That's where my Odin project is focused, in the understanding that everything not included on the CMBD would be considered shadow IT. Shadow IT is a term often used to describe information technology systems and solutions built and used inside organizations without explicit organizational approval. As of today, there are different kinds of departments, marketing, human resources, communication, that have their own budgets, and they outsource things with vendors and providers by setting up IT service without notifying of that to the IT part. This would be one of the main definitions of shadow IT triggered by these departments, but it wouldn't be the one single purpose. I can't tell you exactly how many tins of beans I have in every store around the world and in every warehouse, but I can tell you how many servers are currently running. We had moving from having a limited number of machines to a number of machines that we can create as a click. In this way, I'm included in this view. I'm very interested in this area. Whomever of you didn't come up with the idea of testing 10,000 or 200 machines, I will tell people about my experience after switching off the machine. In the very end, we IT guys trigger and provoke many more problems than people from marketing. These problems causes a lack of visibility for the assets in the company. The assets fully recognized in the company are not visible. Nessus guys describe the whole thing like the glimpse, and I'm using the example of the baked beans on this blog. It's a very, very practical case study. I will be able to tell you how many baked beans I have a story in my warehouses and shops, but I'm not able to tell you how many servers have been set up. Funnily enough, this happens even in the best possible houses. The Homeland Security Department in the States, which is mixtures between the intelligence agency and Interior Ministry or Homeland Ministry in Spain. They have their discrepancies regarding managing their assets. Their departments or some departments start doing their own business individually without going through the IT department. So, this fits in the concept of footprinting. From this footprinting perspective, would be to increase the surface of exposure when expanding this company internet and their assets. This viewpoint that the company is losing from their lost assets, this lack of knowledge and visibility, I can have real value in assets whose real value I don't know. So footprinting aims at these problems. Out of all the things you can find on the internet, I will search those things that are yours, but you don't know that these things belong to you. I knew IP, the addresses, host names, abandoned or forgotten host names, but they're still connected to the structure and the infrastructure of the organization per se. Not only the unattended services and the new one included, but also I could consider the bug bounty from Google specifies a clause that you won't be there will be not any recompensation to you in the next months after purchasing a company, because this new, it's like a shadow IT included in the new acquisition of this company had bought, so the IT part is not recognized as it. Now, footprinting techniques. We can see we are familiar with this footprinting techniques. We have long-term experience. We have especially the techniques of inverse consults for name servers, email servers. From this email server, how many domains I have sharing the very same email server? This is an inverse consult, roughly speaking. We have transfer of zones with DNAs, complete transfer of zone due to bad DNS transfer. We are we are doing illegitimate use of DNS to obtaining subdomains associated with an IP, but I'm doing brute and gross force because I have the information and you don't know it. This isn't abusing. We also have the use of a public database on the different regional internet registries, which shows the whole range of IPs associated with the company you had bought and that form part of the inventory. Who is domains information associated with the domain registry, and is servers associated with this domain, and this is veracious information, rather the DNA's registry type folder, which don't include correct emails in the correct way, in the correct manner. Within these consults, we can find the web page navigation and third-party services such as GraphText, ServerSnip, ViewDNAs that allows you to conduct these inverse consults regarding third parties. Let me give you some case study, an example regarding the footprinting usage. Is something done by people from this website you can see on screen. This coming Saturday will be around here. Roughly speaking, is a company abusing treating their employments badly, and they consider to stroll around the assets of the El Corte Inglés storehouse website, and they search the ranges of IP addresses they have. They find within the internet regional registries a range of addresses with reverse IP domain check published on that IP, and suddenly they discover the typical communication department, which are those having their own budget segmented, and they carried out IT services without the IT department knowing of the situation. These assets are found. They found the vulnerability of this on the CMS with the SQL injection, the herd cell. So we include all the sources from the El Corte Inglés from 2011 to 2016. Obviously, all these reverse consults are not manually done. They are using tools, electronic tools. Among the different set of tools we have desktop tools such as Spiderfoot, set up on Python with its SQL to register previous registrations, and it has a clear limitation. Among all the assets, they will have the limitation that you can only indicate one of them to start the search. They also have the footprinting part. We check the modules. Not all the modules can fit in the footprinting area, as you can see on screen. honeypot checker, historic files. We also have Maltigo tools developed via Java, which is your client. Your visual client, put it this way, in the very end, this is a more exhaustive search, because when you're conducting a rigorous search, if it's Beasley, it would be more difficult. So then you get to the tool FOCA, F-O-C-O. It cannot give us much more than Chema over 4 years. It's a clear example of these problems. For these big button tools, and the big button does all the searches and queries for me without no filter at all, would be to check the domain source, and you can find an email server within the, not within the domain server. So they do a reverse consult, and they swap that around and consider it to be related. We got false positives. They tested falsely positively. This tool has no persistence. All the petitions and requests sent over are, let's put it with, flying petitions and requests. Then let's move on to the various online services, such as Robtext. I don't want to make you bored about. So we will be around this. I'm talking about the Robtext service, as all these third-party services. This poses the question: all the information, all the consoles I'm making, are they keeping all this information for themselves? Here we can, for example, we can look for a publishing house. I put it right first time, the name of this publishing house, and we find a server, MX Google-based server. We do the reverse search on the email server, including this Google server, and if we look further down, we'll find that servers using this let's put it this way, servers of different domains using this very same server for emails, we show us 100. The Google email server will have many more. We can see that it does queries, consultations, but limit the number of results. We also have another example, would be the BMS, allowing us the whois thing. We type in domain of Digital University for URJC, and we'll find through the quiz inversely, it took out all the emails related to this quiz, and we get university emails and the typical the abuse in access or by any service provider. And when doing the reverse search, it has mixed those coming from the university and those using the very same service provider. This is super cool. When you want to start putting many things inside, the financial issues comes in place. We got the nsdumpster.com, which load all the DNS information onto the system. This fits in. This fits in all the games, all the host names. When loading the search, this fills in all the host names. All these tools have deficiencies and defaults due to the cross in the different domains. This will give me a load of information onto the system, and you'll have to match and tie in domains, not as we saw before with wrap tags or the DMS. Roughly speaking, with the problems with the desktop tools, which are big button, and all these problems regarding this information, I come up with this solution. A tool within the Odin context project, a service which is only footprinting based, with detection of vulnerabilities and a various set of tools, some of them including more things. This would be only focused and devoted to footprinting per se. The remaining online parts we can see now on the screen are premium. They can work totally offline by adding a persistency module with all the information of DNS and extra published information on the internet, which will imply zero detection, being investigated with no risks about they knowing they're being sent queries against them, and third-party service won't be able to know about that.
So the automated part is okay, but then we need something which can be kept under control. By that we mean we do a reverse query, and all the domains that have that appear. We don't need to expand the search tree because it might not have a relationship with that. This is what we call automated function under control, and then multiple input values when starting the analysis. With the current tools we would have a problem because they haven't been developed to do intelligence analysis in this way. If we have a range of addresses in the company with different domains, we need to be able to expand the search tree much faster. That solution, as it was proposed, is based on this architecture. The persistence part would be here, including the information downloaded from the internet, with the loader on the elastic side, the database selected for big data in this case was this one, Elastic, because of its features. It's got an API REST, and then it also has the offline modules and the online modules for queries. To make it more clear, what the offline module does is to send requests directly towards the API and the persistence layer. It wouldn't use any third-party services, and then we will have the different online modules that would perform the searches in the internet. If it found something that was not contemplated by us in the persistence layer, it would be downloaded and updated within the persistence layer for the next search. This will keep increasing regarding the size of the information. And then there would be a wraparound engine called Odin on a front-end website. I'll get into greater detail now about the persistence side and moving upwards, so that you can have a complete vision of what is working behind the scenes. I'll clarify everything so that it can be understood properly. So, why we're storing? Well, first of all, in the persistence layer we have almost 2 billion entries, log entries. Basically because of the queries that are not available in real time. Reverse queries. If reverse queries are there, it's because the protocols do not allow for that. So we have whois, NS, MX, and so on. What we will use here is to keep that information on a persistent basis.
Un nuevo enfoque con el tema de certificados.
And then certificates to do reverse queries. For all the certificates we are interested, and the alternative names, in order to find alternative subdomains or different domains for the same certificate. Then we have crawling applied to social media. I'll explain that in a minute. On many instances we see limitations in the servers themselves, in the whois servers. It is not feasible to launch reverse queries in real time because of those limitations. We also have limitations regarding access for port 43. The default limit is 1 lookup per second, and that's why we need to have a persistence engine so that we can play around with freedom with all this. What is being stored? Well, first of all, we have stored 4.7 million log entries, including the regional logs for the internet, Afrinic, Apnic, Arin, Lacnic, and RibNCC. Arin was a bit more complicated because they were reluctant to share their database, but in principle we have all the ranges in IPv4. What is stored? We also stored information on DNS. That's 1.6 million entries. There's 506 million entries, type A, NS, MX, SOA, TXT, whatever. All those entries that can be found when performing a scan with tools like Census, for example. So we store all of them. Then we would have on the X509 certificates with the different protocols, we will have an additional 400,000 elements. They were parsed in order to find the common names, all IPs possible, so that we can perform reverse queries. Then we have DNS SEC, frequently overlooked, for entries regarding DS and DNS key, very few. For those of you who don't know about this, DNS key would contain the public key at the level of each domain, so that you could verify the different entries for authentication of DNS. And then we will have DS, which is a summary of the different public keys so that you can be granted access. That's 2.3 million entries in total. Then we have whois for domains, 145 million entries. Com, net, and info we got from Verizon, and the rest of TLDs to reach that amount came from the CZDS, Centralized Zone Data Services. So we set up a multi-node system to overcome that limitation for each IP address when doing whois lookups. So we launched a massive number of whois queries. Then we have crawling, as I said before. This is what I mentioned. We have analyzed some 150 terabytes of information within the HTML code in order to find out about different Facebook, Twitter, Instagram, and other social media tags, together with Google Analytics and Google AdSense for advertising. Here we have 9.6 million approximately. Most of these have more than one Facebook, more than one Twitter, and so on and so forth. So we performed reverse queries. How do we launch the queries? We have an API, type REST, so that we can access the information that we're interested in. Information that is persistent in the database. As part of that information, and to show you a simple type of query, we will have the ranges of addresses allocated to Reebok in this example. Since we have the entire range, we could look at Europe, Korea, Australia, so different regional registries for the internet that are persistent in our own layer. Another example. We made a query, DNS lookup for a certain domain. Here we would have all the IP addresses associated, as you can see on the example. Not all of them are there. And precisely for this one, DNS key, I'll show you one, which is ready here. Let us assume that we are launching a query to find out about the public key for this domain. Okay. So we launch the query, the reverse query. We get two keys. And as we did for the servers before, DNS, MKey, MX, and so on, here we select this one, the same key. And here, where it says
Vale, pues encontraríamos ya...
So here we would find this. By launching this type of reverse query, apart from the initial domain we had asked for, we have other related domains. This is DNS SEC, another type of search that we can perform in the tool. Then we would have what we mentioned before on certificates. With UPC, which is another university I didn't attend, if we launch the query, it finds alternative subdomains. So domains are subdomains related to those certificates. That would be in the common name of the subject alternative name. On the whois side, we can try something they haven't looked at recently. We could take an email that may seem to be related to that company in this example.
Vale. Y encontramos todos los...
And here we find all the domains that have been registered associated with that email, including others that wouldn't be found by using DNSs. For example, this one here, adslteleco.com. By performing a reverse query, it wouldn't be possible to find this unless this was linked to what we did before. And last but not least, one of the reverse queries that can be launched when doing crawling. This is a really cool one. We select a company with offices in a skyscraper, for example, and then we analyze their accounts in Twitter and Facebook and so on. If we go to this website, we would find this area. If we go into strategy and business, that would be the Facebook site for this company, and just as we did before for the different servers, DNS, email addresses, or whatever comes to our mind, if we do a reverse query, we can find all the assets for that company with this Facebook account. And here we would see an asset in another domain. I can tell you there's no issues with DNS or MX or anything like that. And if we keep looking, here we would have the Facebook page for that company. So the tool becomes your new follower in that social media.
El tema de las consultas. ¿Quién lo consultaría? Pues tendríamos.
So who would launch these queries? We would have the different offline modules. Your offline modules allow you to remain undetected because it sends everything to the persistence layer. And then we would have online modules, which would be another option. They could be activated for brute force for subdomains, zone transfer, supported by other third parties online, DNS Dumpster, Droptex, and others. Obviously, this is focused on the concept of microservices. Based on the concept of single responsibility. What each offline module does is only launch queries of a certain type. If there is a query launched more than once, it is easier to escalate than otherwise. So once we know what is persisting, we would need to find out exactly what Odin is all about. Obviously, the architecture is based around microservices, as I was saying. Single responsibility, where we have developers using Java. If someone comes along and asks you to develop in Python, it's just a plugin. The bottleneck would be here because you only have two hands. If you develop in Java and you want someone that knows Python, it would be a matter of hiring someone new. So it makes sense to select people that know about different techniques. That is the architecture, the microservice architecture around. In order to achieve as much scalability as possible. Because all of these queries
Orquestada, pues la forma de orquestarlo.
Should be orchestrated properly. The search tree is prone to organizing a chaos, if you know what I mean. We would use the hub and spoke EDA pattern Each module subscribes to a messaging broker and sends messages within the infrastructure are associated to the users creating those messages, to the analysis and to the route they follow. They have their own information associated to them. It doesn't matter in which order they're processed and in which order they go through different modules. And that is the reason you don't need to do everything sequentially.
Bueno, entonces por eso estaría fundamentado en el tema de...
So, hub and spoke EDA pattern. That would be for orchestration. There's nothing doing dispatching. When you see a message that hasn't been processed, it just grabs the message, processes the message, so that the next module downstream will grab whatever comes out of it. So after that snapshot to describe the platform, we have an interface. My disclaimer is that when they were working on the front office, I was somewhere else, but let me show it. This is the Odin tool that we want to show you.
Venga, espera. Fallo técnico. A ver. Vale, esto sería el personal dashboard.
So that would be the personal dashboard. With the different searches that you have performed using the system. I'll tell you in a while about this. And then, as we said before, in the solution you propose, you have the create new analysis page. Here just type the ID. You can add any address range for IP addresses that you know of for your company, all the domains you know of, all the interfaces you know of. You can also enable online security modules or just leave them off by default. And then for identification of internet ranges to be easier, you can click here. This would show you all the ranges associated with it. We could go back to recent searches and perform another search on them.
Y vemos que bueno, pues es brutal la
The amount of ranges is simply amazing for this company. So we could add different ones, and that way we will have an analysis to be performed on those known ranges of IP addresses. Then we will have the domains separated by commas and different IPs. So we would run the analysis, and it would be shown in the personal dashboard as one of the active analyses. If we had an analysis running, the window would show it here. If we want to take a look at the results, we could go to the ULL, the University of La Laguna. We click on View Details to see the inventory of assets. Here we would see that we have a set of IPs, a number of services associated. This is for internal rerouting. We will have the different ranges for IP addresses with different descriptors. And obviously, We could go to another university, the UEM.
Pues aquí sí que se hace más llamativo de que yo tengo identificado.
Here, it is even more striking. You have IPs, ranges. How do we keep this under control? As we saw in the dashboard, it tells you that you have pending tasks. That pending task area allows you to do this. The analysis was run first with against 4 assets. I know 4 IP address ranges, or 2 ranges and 2 domains. With that information, Odin does a search offline. If we go into information pending, we see that it has discovered other things in other IP ranges, associated domains as well, different NS servers, this one, for example, seems to belong to the domain. In that case, we would approve it, so we would extend the space to analyze. Whereas these ones that are not associated to the main domain, we would simply deny, so that they would be eliminated from the search tree. That way, we keep everything under control. We allow the user to approve or deny, because they have the necessary information in this case. And that way we keep things under control for NS, MX, and for WHOIS, if that is available.
Bueno, y para terminar,
And by way of conclusion,
el proyecto Odin, pues tenemos intención de...
this is our timeline for the Odin project. In October of 2015 we started everything. We will be in the 100B release right now. We intend to move over to the next release by this summer. We would like to see a number of companies getting to work with the tool so that they can use the different elements, launch searches, or use the API or the on-demand website. We would like to see the website on demand available by this summer, so we know who gets in and the type of usage that we can find. And by the end of this year, we would like to have the next version. Main conclusions is that whichever way we call it, glimpse, shadow IT, or I have no idea what my company does, we have a reality around us. We have organizations.
Controlarla mediante las buenas prácticas, por así decirlo.
Best practices are not good enough. They're not enough. We need to find other alternatives. In order to do footprinting, we need to bring order to that chaos. Yeah, and it is obviously not necessary to use third-party services. All those tools, with big button tools, have a very high number of false positives. They go out of control. But if we add an area which is more manual, which allows users to make decisions, we bring some order into that chaos. And as regards footprinting in general, there are many different ways, there are many different options for further improvements and for innovation in this field. as we saw with NS and crawling for social media. My acknowledgements in the Odin project, these are the two guys, that's me and Alex. So any doubts you may have, any suggestions you would like to make, please feel free to get in touch with me or my colleague. I would like to thank the organizers, of course, for their time. And I would like to thank Yoya Silva for her help and invaluable help in gathering information about who is, searches, and everything we have included in our systems layer. These are some references. And I'm open to answer any questions.
Hello. I mean the online version. What kind of scripts do you need for online version and the legal implications as using this motto regarding all the online scripts? We have to cope with certain problems. We had proposed input forward in this minimal and functional version with the purpose for all of us to have it clear is as follows. In this version, I can achieve the objective that is totally undetectable. There are certain features we haven't included because we weren't able to control these kind of problems. As we filter out these problems, we'll be offering online modules online. We are conducting parallel works and tasks to wrap it up as soon as possible. Do you mean are you tackling ports? This question fits in more within the Alex mindset. Alex can give you extra feedback about your question. Please, there is no microphone in use. There is no microphone in use. There is no microphone in use. The microphone is off. Now, the Odin idea is for you to have your own installation and you can analyze your own system. The problems is not only about people doing hacking, but also for IT departments to manage their own assets. So it has not to be illegal per se. Myself as a security person manager, it targets your own department of security. You can conduct it on other systems. It will go against you, not against the public domain services. So Elías bears in mind for the next latest update. Thank you, Elías, for your nice presentation. So let's